Hi everyone. So we're looking at simplifying complex fractions. If you've been watching parts 1 through 3 of my videos in this little series, I showed method 1 and method 2. Method 1 I showed in my part 1 video was actually this problem doing method 1. Parts 2 and 3 I did using method 1 and then method 2 on a same problem with those. Now let me come back to my original problem that I did in part 1 and show you how to do this using method 2, alright? If you watched part 3, like I said, we did method 2 in there. And what that composed of is I've got all these little fractions here. I've got the x plus 3 over x, I've got 4 over x minus 1, I've got x plus 1 over x, I've got x plus 1 over x minus 1. Let me circle all the little denominators within these guys. Alright, with what I've got circled, what is your least common denominator? If you said x times x minus 1, then you'd be spot on. So what I'm going to do is I'm going to multiply numerator and denominator by that x times the x plus 1. Now, something I neglected to do in part 3 of my video when I initially showed method 2 was what I ended up doing was I multiplied each little fraction by that LCD. But let me explain in this one why it works the way it does, okay? So what you do to the numerator, you would do to the denominator, right? So if you multiply the numerator and denominator by x times the x minus 1, what you're doing is you're distributing that x times x minus 1 into the parentheses, right? So, well, I kind of wrote myself into a corner here. Let's see if I have room. So what you're looking at here is this x plus 3 over x times the x times x minus 1 minus this 4 over x minus 1 times the x times x minus 1. I don't have much room. Down here I've got x over x plus 1. Excuse me, x plus 1 over x times the x times x minus 1 there, plus x plus 1 over x minus 1, and that times the x minus 1. So really, I could have bypassed this step where I showed the numerator and denominator getting multiplied by x times x minus 1. I could have gone straight from the original to this step, and that's what I did do in part 3. Makes it a little faster, you're saving yourself a step, and to be honest, I don't know about you guys, but I feel like I'm looking at something John Madden put together back when he used to do Monday Night Football where he drew arrows everywhere. It drove me nuts, especially when he started going in reverse all the time. I was getting like motion sickness just watching him. Alright, well, let's look at what we've got here. These x's drop. This x minus 1 divides out. This x divides out. And this x times x minus 1 divides out with that other x minus 1. So again, like I said in part 3 of simplifying complex fractions where we used method 2, what I like about method 2 is that you're going to get rid of those extra fractions in a big hurry. So now we're looking at x plus 3 times x minus 1 minus the 4x, all that divided by x plus 1 times x minus 1 plus x plus 1 here, and that all gets multiplied by the x, which I'm actually going to put out in front here, like that. Let me pause the video so I can erase this stuff and move what I've got right here up to my top left so I can have some room to work with, alright? Okay, I've transferred it from my bottom right to the top left, and I erased everything else. Parts 2 and 3 of working with complex fractions, those videos, I showed method 1 followed by method 2, and I remember on that one, because I did those tonight, method 2 in that particular problem was easier than method 1, at least for me. What I don't remember was part 1 when I did this original series. It was a few months ago actually when I put that together, and I did this problem using method 1. I can't remember how hard it was to get to the answer. This one's starting to turn out to be a little bit lengthy, because what I need to do now is I need to distribute. I need to multiply out these two binomials, and I need to multiply out these two binomials, and I need to distribute this x through this binomial here. What you don't want to do is try to reduce this x minus 1 with this x minus 1. Okay? I know that's a temptation, but don't succumb to that temptation. The reason you can't do that, this minus sign here and this plus sign here. The only time you divide out fractions, or the only time you can divide out factors, is if what you're trying to divide out is getting multiplied to everything in the numerator and getting multiplied to everything in the denominator, okay? With this minus and this plus here, that's not letting that happen. So like I said, we've got some distribution that has to happen. X times x is x squared. Outers, minus 1x. Inners, plus 3x. And last, 3 times negative 1 is negative 3. Still got my negative 4 here. That'll take care of my numerator for now. X plus 1 times x minus 1, that's just the difference of squares. X squared minus 1. Over here, we've got x squared plus 1x. Alright, so I've distributed everything. Again, don't succumb to the temptation of trying to cancel these x squares. You can't do it. The minus signs, plus signs, all over the place. It's not letting you do it. So let's collect by terms and see where that takes us. Numerator. I only have the 1x squared there. Let's see, for my x terms, I've got negative 1x plus 3x is 2x. 2x minus 4x is a negative 2x. And I've got my minus 3 there. Downstairs, x squared and x squared is 2x squared. And then I got my plus 1x. I'm just going to write plus x there. And then minus 1. So I'm putting these guys in standard form. Now, the question is, are these guys reduced all the way? I don't know yet. Let's find out. Let's take a look at our x squared minus 2x minus 3 real quick. That should factor kind of quick. X minus 3 and x plus 1, I believe, right? Let's take a look at this denominator here with 2x squared plus x minus 1. Let's see if I can factor that real quick. Yeah, it does. It's going to factor nice. Okay, so these guys are going to factor. We've got x minus 3 times x plus 1 in the numerator, and 2x minus 1 times x plus 1 in the denominator. Oh, look at that. My x plus 1's divide out. In the end, I've got x minus 3 over 2x minus 1. So that took a while to get to. Geez, I filled this board up twice in this problem, almost. And I can't remember how long it took to get this problem done using method 1. I have a nagging suspicion that it might have been faster using method 1 on this problem. So, do I have a recommendation as to when to use method 1 versus method 2? How do you know? You kind of have to look at it. You have to get kind of good at both methods in order to pull it off. So, my recommendation to all of you watching would be, it's easy to get these two methods screwed up. Okay, so if you're taking my online class, I'm actually going to send an announcement out to you guys to just probably pick method 1 or pick method 2 and just stick with it and don't watch the other videos because it screws you up. It really does. So I'm just going to leave it at that. All right, thanks for watching.